Welcome to lesson number 2, trig ratios for angles from 0 degrees to 360 degrees. Today we'll be talking about the Pythagorean theorem, which you know as c squared is equal to a squared plus b squared. But for this unit in trigonometry, we are going to use a different formula, which says the exact same thing. The formula we're going to use is going to be x squared plus y squared is equal to r squared, where r must be greater than 0. The point P in terms of xy lies on the terminal arm of angle theta, and the distance from the origin to point P is r, the radius of the circle formed by the rotation. At this point of the video, you might be wondering, what is the terminal arm of angle theta, and what is point P in terms of x and y? Point P is the point along the x and y axis. X and y. And the terminal arm starts at the origin and ends at point P. The distance from the origin to point P is the radius of the circle in the angle of rotation. Let's take a look at class example number 1. Sketch the rotation angle in standard position and calculate the exact distance from the origin to the given point. Where appropriate, write the answer in simplest mixed radical form. Example A, point P at -5 and 12 on the terminal arm of angle theta. To begin this question, the first thing you need to do is sketch the x and y axis. Next, we're going to place point P at -5 and 12 on the grid. Now the final part of this question was to calculate the exact distance from the origin to the given point. The given point being point P at -5 and 12. Remember, we're going to have to put this in simplest mixed radical form if necessary. After determining what is going where on my x and y axis, since I'm looking for the value of r from the origin to point P, I know that I need to use Pythagorean theorem. And remember, in trigonometry, for Pythagorean theorem, we are going to be using x squared plus y squared is equal to r squared. From here, I'll just fill in my known values of x and y. So r squared is equal to -5 squared, being x, and 12 squared, being y. Therefore, r squared is equal to 25 plus 144. R squared is equal to 169. Remember, this gives me r squared, it does not give me r. And so in this case, I'm going to have to take the square root of both sides, and r is going to be 13. Okay, let's continue with example B. On example B, we're going to be doing the exact same thing. So we're going to start with just drawing our x and y axis. So my y-axis going up here, my x-axis on the horizontal. Now it says for point Q is going to be at -2 and -6. So -2 will be our x value, and -6 will be our y value. And then we want it on the terminal arm of angle A. So for this example, since -2 is on the x-axis and -6 on the y-axis, so that's -2 to the left and -6 going downwards into quadrant 3. And in this example, we're told it's point Q. So those two coordinates will make up point Q. Now, just like example A, we're looking for the distance of r. We want to find the exact distance of r. So we have -2 on the x-axis, and we had -6 on the y-axis, like this. And so just like last time, we are going to use our formula of r squared is equal to x squared plus y squared. Again, where r needs to be greater than 0. And so let's fill in our known values. I have r squared, and that's going to be equal to x squared, which is negative 2 squared, plus negative 6 for y squared. And again, remember, this is going to be equal to r squared, not r. And so negative 2 squared is 4 plus 36. And so r squared is going to be equal to 40. But remember, we're looking for r. And so in order to find r, I'm going to have to take the square root of both of these sides. Now going up, I'm going to be left with r is equal to root 40. And I notice that in the question, it asks me, where appropriate, write the answer in simplest radical form. And so I know that that's square root of 40 can be simplified to the square root of 4 multiplied by the square root of 10. So my distance in simplest radical form will be left as 2 rad 10. And that is my final answer. Okay, so you may remember from pre-calculus 10 and physics 11 when we studied trigonometric ratios. And those trigonometric ratios were in the form of SOHCAHTOA. So being sine, opposite over hypotenuse, ka being cosine, adjacent over hypotenuse, and toa being tangent, opposite over adjacent. And so all of our sine ratios will follow this mnemonic. So if you're having difficulties remember which sine ratios are which, just follow SOHCAHTOA. Let's begin with SO. SO is our sine ratio, and our sine ratio is equal to sine theta equal to opposite over hypotenuse. And so that would be the opposite side divided by the hypotenuse, and that ratio would give you angle theta. If we're looking for the cosine ratio, we would use the second in our mnemonic. Cosine is equal to adjacent over hypotenuse, and we would do the exact same thing. We look for the adjacent side divided by the hypotenuse, and that would give us, again, angle theta. And then lastly, we're left with toa, which is equal to tan theta, which is equal to opposite over adjacent. So these ratios are called the primary trigonometric ratios. And again, remember them by the mnemonic or the acronym SOHCAHTOA. Okay, so let's move on to this class example number 2. Write the primary trigonometric ratios for angle theta in terms of x, y, and r. So recall in the first example when we examined a triangle and an angle which forms a radius around a circle, like that. And so remember that we used the Pythagorean theorem where r squared was equal to x squared plus y squared. And so in using this right angle trigonometry rules, we can use sine theta is now equal to y over our radius. Since y would be equal to our opposite side, x would be equal to our adjacent side, and r would equal our hypotenuse. So every time with these trig ratios, in terms of angle theta, and especially in terms of x, y, and r, we can rewrite our trig ratios in order to take the place of these x, y, and r values. So cosine theta would be equal to x divided by r, and tan theta would be equal to y divided by x. Moving on to class example number 3. The point 15 and 8 lies on the terminal arm of an angle theta as shown. Calculate the value of r, and hence determine the exact values of the primary trigonometric ratios. The first thing we need to do is think about what information do we have. we know that the point 15 and 8 lies on the terminal arm of angle theta, as shown. So I need to recall my terminology, and I'm going to recall that my terminal arm is right here, which means that this point must be 15 and 8, which tells me that I have an x value equal to 15, and I also have a y value equal to 8. Since I know my x and y values, I can determine what my r value is going to be. Again, we're going to use our Pythagorean theorem, which is r squared equal to x squared plus y squared. R squared is going to be equal to x squared, which is 15 squared plus 8 squared. R squared is going to be equal to 15 squared plus 8 squared is going to be 289. And again, remember that this r squared is not going to be our radius. Okay, so we're going to have to take the square root of both of these to determine what the value of r is going to be. If I take the square root of 289, I'm going to be left with 17. Now I can begin to find out what my exact trig ratios are going to be. I need to find out my exact values of my primary trig ratios. So recall that for our trig ratios, we need to use our mnemonic SOHCAHTOA, and instead of all of our opposite and hypotenuse language, we're going to be using the language of x, y, and r. And so I need to think about what sine theta is equal to. And so sine theta is normally equal to opposite or hypotenuse, but in this case, I'm going to be equal to y divided by r, my radius, which is going to be 8 over 17. There's no need to simplify any further, since 8 is only divisible by 8 and 17 is not divisible by 8, and so I can leave this as 8 over 17, and that will be in simplest terms. So then I can move on to cosine theta. Cosine theta is equal to x divided by my radius, or my adjacent side divided by my radius, which would be equal to 15 divided by 17. Again, I can't simplify that any further, so I'm just going to leave it as it is. And then finally, I'll finish with my tan ratio, which is equal to y over x, or opposite over adjacent. And that would be equal to 8 over 15, since I know that my y value is equal to 8 and my x value is equal to 15. And there we have it, and that is our final answer for class example number 3.